And hello, everybody, and welcome back. Picking up with mobile devices, SMS text or short message service. SMS text is a text messaging service component of most telephones. Really fabulous. It uses the internet and mobile device systems. As opposed to MMS, which is multimedia messaging, which is a standard way to send messages that include multimedia content over the phone or the cellular network, right? These are things like PXT files, a picture message, multimedia message, right, etc. Be aware, too, that voicemail is going to convert an analog voice message to a digital form that the computer can use. Human speech is in analog, or this continuous waveform type of signals. It's continuous signals. Most computers, though, are digital. They don't operate in continuous signals like humans. They use only two discrete states, on or off. And so a voicemail is a storage location on the hard drive that is storing that on or off, those two discrete states, but translating it into a sort of human speech, that analog speech. So VM users can view details oftentimes on a voicemail, like the length of the call. They can even read the contents nowadays, which is really spectacular. Okay. Then we have some digital cameras. Be sure in the next few slides to review on your own pages 3-19 and following of the book. I think you'll find that very helpful. Same with these mobile devices, more on how digital cameras work. Very interesting if you enjoy that sort of thing. It's a good read. Okay. Now I wanted to get to embedded systems. Embedded computers are a special type of computer. So an embedded system is a computer system. It's a combination really of a processor, a computer processor, computer memory, in and output peripheral devices that have dedicated functions within this larger mechanical or electrical system. So they are everywhere. They're in your car, in your home, at work. In fact, consider this concept I asked you when diagramming your home computer network for your course project, right? Read this section in the book carefully. Consider printers, for example, which have embedded computers inside of them to monitor the amount of paper remaining and warn you, to check the ink that's left, to advise you if there are paper jams. Very helpful. So embedded systems are similar to computer systems, perhaps even a chip, right, that are used as a component, again, within this larger system, such as industrial controls or smart homes, manufacturing, even printers, as I just mentioned. Okay. So then moving to continue with embedded computers. The book asks, I think, a very interesting question. Can embedded computers use the internet to communicate with other computers and devices? Well, yes. That answer is both exciting and frightening. Many already do on a small scale. For example, a smart TV enables you to browse the web and stream video, etc., all while watching a TV show, right? Very exciting. This really becomes part of the IoT, or we call it the Internet of Things. And the Internet of Things describes an environment where processors are embedded in every product imaginable, which are things, and those things communicate with one another via the Internet. So this part of your home would include alarm clocks, coffee makers that are automatic, applications, vehicles, refrigerators with smart pads on them or other things, phones, washing machines, doorbells, streetlights, thermostats, and even navigation systems, to name a few, right? The Internet of Things are these billions of physical devices around the world that are now connected and all sharing data, right? From even airplanes have thousands of embedded computers on them. So very interesting world that we live in. Putting it all together then, just to simplify it, boil it down a little bit, this slide shows the 6 categories of computers and mobile devices. This is really meant to simplify things a bit. Not sure if it does, because it's ever evolving. But hey, at least they tried, right? I'm pretty happy with that at this point in the course. Now, on computers, since we've talked about so many, we want to talk about a port. A port, sometimes we refer to as a jack on our computer, allows a device to connect to peripheral devices through ports using some wireless, or maybe by even using wireless technology. So we can connect through a port physically, or we can connect in a wireless way. It is at the port that the device communicates with the computer or the mobile device. This is the input and output mechanism. So the port serves as this interface between the computer and other computers or peripheral devices, right? Very, very interesting capability. A connector is just as it says here, it joins the cable to the port. You have this connector that you're actually plugging in, right? Simple concept. And here are some of the types of connectors. Notice the multiple types of USB ports. USB standing for Universal Serial Bus Port. So a computer port is, as we talked, an interface or point of connection between the computer and these peripheral devices. Some common peripheral devices that you have are a mouse, a keyboard, a monitor or display unit, a printer, a speaker, flash drive. Right now on my computer, my keyboard is wireless because I have an adapter plugged into my USB port, right? Communicating wirelessly with my computer. Very interesting. Okay. Now, a USB port can, so not just the one port on my computer, because the smaller these computers get, the fewer ports you have on your computer. But you can get adapters, you can plug up to 127 peripheral devices into a single USB port. So there's quite a bit of capability as we make computers smaller and smaller. Now, newer versions of ports are also considered backward compatible, which means that they support older USB models as well as newer USB models. Okay. Now, instead of connecting physically with peripheral devices through a cable and a connector that we talked about, sometimes we do it wirelessly. I just mentioned my own keypad on my computer right here is not actually physically connected to my computer. It still operates wirelessly. And there are various types of wireless communications: Bluetooth, Wi-Fi, NFC, and ANT, or antenna. NFC stands for Near Field Communications. These are devices that automatically within range they'll connect, right? You sometimes do this with your phone and a payment system, when you hold your phone up to a payment system when you're checking out of a grocery store, right? Security issues can arise if someone, say, loses their phone or the phone is stolen, so you want to be careful always. So just be aware of that. Antenna. We want to use that as able. That's a proprietary technology that Garmin has. It is mostly used in your wearable devices, like a fitness center. It's a low-powered wireless technology with a range of about 30 meters. And ANT is susceptible, of course, to eavesdropping, interception, and impersonation, so be careful. Now with the Bluetooth, we want to make sure we pair devices together. Pairing is the process of initiating contact between two Bluetooth devices, allowing them to communicate with each other. So when you turn your devices on that you want to pair, ensure they were within range, of course, which is a short range. It's only like a few feet, maybe 4 feet or so. And then you want to place one in discoverable mode, and the other phone will be in secure mode, and it will probably give you a pass key. So it's like a PIN, right? That the other person will enter to make sure you've only paired to that phone. Otherwise, if you're just open, others could pair with you and you wouldn't even know it, and they could be sucking your data. They could be looking at your information on your phone and downloading it. So be careful with that, but it's still useful technology. These are some of your wireless standards for Wi-Fi. There are 5. First we started out with, and they're all 802.11 on a frequency range. And they go from A, B, G, N, and currently AC. And you see as they grow that the frequency will grow, that this transfer rate accelerates. So in 802.11 AC now we're up to a gigabyte per second of frequency transfer. It's phenomenal, right? You see the range has stayed fairly consistent over time, and 802.11 AC is backward compatible with all the others. Very interesting. Also be aware that any wireless device using 2.4 gigahertz range, that's similar to a microwave, right? And so you could actually get interference. If you have interference on your network, it may be because of other microwave signals nearby. Interesting. Okay, now protecting hardware, right? The book makes an excellent point about being cautious when plugging your USB cable into charging kiosks meant for public use. The term that can happen to you is called juice jacking. Juice jacking is when hackers steal your data or transfer your malware. So they want you to plug it in for power, knowing that Bluetooth has really 2 purposes. It's to charge and it's to sync, right? And they're counting on the sync function, synchronization function, right? So we want to be cautious of that is all I would offer, okay? Now, biometrics is a new and exciting approach, right? Like the fingerprint, like facial imaging, the palm print. Biometrics is a technical term for body measurements and calculations, right? It's really about metrics related to human characteristics. And biometrics authentication is used in computer science as a form of identification and access control. It is also used to identify groups, right? We are working on a form of biometrics right now where I work. Very exciting capability. Turns out that of all the authentication capabilities, loading a PIN, loading a password, biometrics is the strongest by far of all of them. And facial recognition, probably one of the best. Many of you probably have a personal home computer that recognizes your face and gives you access. You have authorization to use that computer. Very exciting. So we want to continue to protect the hardware against undervoltage and overvoltage. It's not just about total power failure that can harm you. Overvoltage conditions like surges and spikes and undervoltage can do irreparable harm or damage to the system. There's some good words on that in the book. So enjoy that read. That really does kind of wrap up chapter 3. This is good stuff about the uninterruptible power supply. You want one of these to protect from those sort of surges that we just talked about, over or under surges. And then there are some healthcare concerns. You may have had some of these. Please read the book to review those. Okay, that's all I've got. I've enjoyed our time together in chapter 3. I look forward to the discussion, the homework, the labs, and just spending time with you. Give me a call, send me an email as I can help. I'd love to connect. Thank you.